Hi, welcome to this video on rounding and estimating. In this video we're going to have a look at rounding to decimal places as well as significant figures, and then we're going to apply that knowledge in terms of having a look at some estimating questions. Alright, if you could copy down or pause the video right now and copy down the important notes. They might not make sense just yet, but by the end of the video they hopefully will do. Alright, I'm assuming you've done that, so let's carry on with the video. Alright, so the questions here are very often kind of round this number to the nearest 100, round to the nearest 1,000, or if we talk in terms of decimal places, round to the first decimal place, round to the third decimal place, or in terms of significant figures, which I'll get onto after we do the first two, round to the first significant figure, round to the third significant figure, these sorts of things. So that's what we're going to have a look at. We're going to start off with rounding to the nearest 10. It doesn't have to be the nearest 10, it could be to the nearest 100, but the idea here is I have to work out what the nearest 10 is. I'm given the number 12, the number 17 and the number 15. I'm going to round them to the nearest 10. So it's either going to be 10, or start with 0. It could be 0, 10, 20, 30, 40, 50. It's going to be one of the 10s. It could be 110, it could be 1,210, 1,220. Doesn't matter where the number falls, but I want to round it to somewhere a multiple of 10. So this tells me I'm going to be rounding to a multiple of 10. And the principle here is, if I have a number line, I'm going to try and see what my number fits in between. So, and we're looking at multiples of 10. So 12 clearly fits between 10 and 20. Now it just so happens that all the other numbers also fit between those. I've deliberately done that to illustrate a point, which you'll see in a moment. But that will be my first step. I'm trying to think of what could the answer be. It's either going to be this or it's going to be this. And the idea here is I have to think, well, which number is this close to? So clearly 12 is going to be closer to 10 than it is to 20. So if I were to round 12 to the nearest 10, it's going to give me 10. 17 is definitely closer to 20. So 17 is going to round to 20. Now the problem comes in when I look at 15. Because 15 is actually slap bang in the middle there. Okay, so 15 kind of sits on this dot, or on this dotted line right there. So there's the number 15. So does it round down to 10 or does it round up to 20? And this is actually the key, because not only will 12 round to 10, but every number on the left-hand side of 15 will round to 10. Every number to the right of 15 will round to 20. And that includes, it could be 12.153, or that will still round to 10. It could be 14.999. That will still round to 10, right? 17.153. It doesn't matter where it sits here. It could sit right there, it could sit there. It will still round to 20. And the reason for that is because this tells me where I am in terms of the middle. So everything on that side is less than 15. Everything on that side is closer to 10. Everything on that side is more than 15, so therefore closer to 20. Now the problem comes in terms of 15. We're still stuck with this. So mathematicians kind of had made the decision that if it is 15, if it is right in the middle, we're just going to round it up. Okay, so 15 here is going to round up to 20. So the answer to 15 rounded to the nearest 10, that will give me 20. And from this I can kind of start working out that this number in the middle, this 15, is actually the most important number, specifically this digit there. We'll revisit that in a moment. I just want to have a look at the decimal rounding. So here I want to round to the first decimal point. Okay, now my first decimal point is that one there. Okay? That one there. Now, that means that this number is either going to be 2.1 or it's going to become 2.2. Alright, so let's put that down on my number line, 2.1 and 2.2. Now I'm going to continue with this. I'm going to think, okay, where is my middle? What number is going to be in the middle? And very quickly you could add on another 0 there to make it even more obvious. I can see that this is going to be 2.15. Just a note, by the way, that's pronounced 2.15. It is not 2.15. 15 is a very different number. We pronounce our decimal numbers individually, or decimal digits individually. Alright, so 2.13 I can then clearly see is going to sit on this side, where it is probably about there, but that means that this will round to 2.10. 2.19 is definitely very much falling down there, somewhere in this region, and so therefore it'll round to 2.2. I suppose we can get rid of that 0. 2.15 again sits in the middle, but we know that even if it is in the middle, it's going to round up, so therefore this becomes 2.2 as well. I'll remove these zeros here just to maintain the question there, so 2.2 or 2.1. And again, this middle number here is actually very, very important. Now, something that should jump out to you is, I asked for the first decimal place, and the number that's the most important, most critical, is the decimal place afterwards, so the second decimal place. In this case here, I asked for the nearest 10. There's my 10, but again, the number to the right, in this case the 5, became the most important. And the reason for that is that designates halfway. Right? So halfway is very, very important, because if this number here is bigger than 5, let's say I wanted to round to the nearest 10, I wanted to round 19 to the nearest 10, I can straight away tell it's going to be near 20 because the 9 is, or it's going to round to 20 because the 9 is bigger than 5. 5 becomes the most important number. Well, not the 5, but the... no, 5 becomes the most important number, but certainly the position afterwards, so my units column. If we were to expand this a bit, let me erase these top ones here. Let's say I wanted to round 265.1 to the nearest 100. Okay, first I've got to make my decision. It's either going to be 200 or 300. Right? There's 265.1 sits between those. But 265.1, that's bigger than halfway, because we know that halfway is going to be 250. It doesn't matter how much bigger than halfway it is. If it's bigger than halfway, or halfway itself, it will round up. So that, rounded to the nearest 100, is going to give me 300. So 265.1 rounded to the nearest 100 gives me 300. And from this I can start working out a pattern. And there's a little bit of a mnemonic, well, not necessarily a mnemonic, but certainly a memory aid. All you need to do is find your number. So if we do the experiment, let's make it 20.526, and I want to round this to the second decimal place. Second decimal place. So first thing I've got to do is I've got to find my number. I'm looking for the second decimal place. There's my number. That's the digit I'm looking for. That's the digit in the second decimal place. If I was looking for the third decimal place, it would be the 6. If I was looking for to the nearest unit, it would be the 0. Okay? I find where my number is. I look to the right. I look to the right, because what I'm now looking for is this number bigger than halfway or less than halfway in between my either 20.52 or 20.53? Is it bigger or less than halfway, which will tell me which one it rounds to? Clearly here, it is bigger than 5, because 5 is halfway. So this means this is going to round up. So 20.53 it becomes. And here we get the last line of this little memory aid, 5 and up, rounds up. Okay? So I find my number, I look to the right, 5 and up, rounds up. Cool? 5 and up, it goes up. If this was 20.523, 20.523, find my number, look to the right, 5 and up, rounds up. No, it's not 5 or up, so it stays exactly the same. So that 2 there stays the same. Remember, it's not the 6 that, it's not the 3 that's changing, it's always my number that's changing. It's the 2 decimal places. That's either going to move up or stay the same. We talk about rounding up, and then we talk about rounding down. It's a little confusing because rounding up, the number moves up, but rounding down, the number actually stays the same. And this digit here doesn't change to a 1. Very common mistake, be careful of that. And you can avoid doing that by realizing that your answer is either going to be 20.52 or 20.53. That's a very important thing to realize. And the reason you know that is because this number sits somewhere in between these two numbers. Okay. Significant figures. Significant figures are very similar in how they work to our decimal points, or decimal rounding that we've just done, our decimal places. The only change is where we start from. So the decimal point was the starting point for rounding to decimal places. If I said, if I had a number 3.521, I asked, what's the first decimal place? Straight away you'll be able to tell me that's the first decimal place. Second, the second, third is the third. I'm always starting from the decimal point. Okay, I'm always starting from the decimal point. Significant figures start differently. If I gave you number 25,261, and I said, actually let's change that to 29,000. Right, and I said to you, that is actually the amount of people who were in a stadium. Okay? The amount of people in a football stadium. And there was a headline, something people at the football match. How many people at a football match? You look at that and you think, well, what would that number be? What might the newspaper think? They certainly wouldn't say 261 people, or 200 people, or 9,000 people. They wouldn't be saying that. They would round to the most significant number, the number that's the most important. Which in this case is the 2 there. Right? So they would round to the most important number. So they'd round somewhere in the 10,000s. Right? So the way we identify where to start when rounding to significant figures is from the first non-zero digit. Okay, and that's for significant figures. Sorry, I should have put that note there. Please take a note of that. For significant figures, we start from the first non-zero digit. I'll explain what non-zero means in a moment. So if I were to start counting and numbering, just like I did with the decimal rounding, this would be my first significant figure, my second, my third, my fourth, and my fifth. If I throw in some decimals to a different number, let's say 25.961, my decimal counting, if I put that in green, this is my first decimal place, my second, and my third. But in terms of my significant figures, there's my first, my second, my third, my fourth, and my fifth. So looking at the second example, if I were to round this to 2 decimal places versus 2 significant figures, these, by the way, are the abbreviations. It's usually 2DP or 2SF. That's what you'll usually see in your exams. Let's say I wanted to round this to 2 decimal places. Well, here is my second decimal place, so I look to the right. So this is either going to be 25.96 or 25.97. We know that from the previous exercise. 25.97 is not going to be the answer because that needs to be 5 or more in order to increase that to a 7. So to 2 decimal places, this is actually 25.96 because that 1 does not change the 6. Rounding this to 2 decimal places, however, here is my second decimal place, the 5 there. I do exactly the same thing. I look to the right and I ask myself, this is either going to be 25 or 26. My second decimal place happens to be in the units column. So that becomes 26 because the 9 is bigger than 5, or is 5 or more, and it changes the 5 into a 6. So you can see here straight away very different answers. The non-zero digit part starts to make sense when I give this sort of question. So decimal places, if I were to round that to, let's actually put in another 0 here. Right, let's put another 0. If I were to round that to 2 decimal places, right, 2 decimal places, and I was also asked to round it to 2 significant figures. Right, let's see what happens here. So 2 decimal places, if I start numbering my decimal places, I've got 1, 2, 3, 4, 5, and 6. Significant figures, however, I'm going to start counting from the first non-zero digit. So I'm not going to start there. I'm actually going to start here. 1, 2, and 3. So to 2 decimal places, well, here's my second decimal place. My third decimal place is actually a 0, so that's 0.00. Please note, if they ask you for 2 decimal places and one of them happens to be a 0, please put them in, right? Don't leave out a 0. 0.30 rounded to 2 decimal places is 0.30. It's not 0.3. That's to 1 decimal place. You need to show the decimal places. Back to this problem though. To 2 significant figures though, that's relatively easy because it's 0.000. Here's my second significant figure. The 9 is bigger than 5, so the 2 becomes a 3. So that's 5, 3. And that's the 2 significant figures. And you can see the difference here. You can see how powerful significant figures are because 2 decimal places kind of fall flat if I'm working with really, really small numbers. Okay, so that's rounding to significant figures versus to decimal places. The key difference here is where you start. From the decimal point with decimal rounding, or from the first non-zero digit with significant figures rounding. Okay, now the next step of this is estimating, and it uses significant figures. Let's say I was given this question, 362 times 211. Okay, and I was asked to estimate the answer. Okay, estimate the answer. Now when you see estimate, it means to 1 significant figure. It's the questioner, the examiner is asking you, please can you round that to 1 significant figure, that to 1 significant figure, and then multiply them. Right, so 362 to 1 significant figure. If I start numbering here, these are my significant figures, 1, 2, and 3. I'm starting from the front. 1, 2, and 3. That to 1 significant figure, so it's either going to be 300 or 400. The 6 tells me it's going to be 400. And this 211, that is either going to be 200 or 300. So it becomes 200 because the 1 is less than 5. So 400 times 200, I can quite easily do that. 4 times 2 is 8, with 1, 2, 3, 4 zeros afterwards. Gives me 800,000. So an estimate to this answer, and I use a curly equal sign to show it's an estimate. That'll be approximately 800,000. If I actually take my calculator and I put in 362, times it by 211, I end up with 76, oh sorry, that comma's in the wrong place there, 76,382, which obviously is very close to 80,000 in terms of an answer. So this as an answer will be entirely acceptable as an estimate. Okay. When you see estimate, it's asking you to round to 1 significant figure. I'll do one more example of that. So we are asked now in the question, please estimate the answer to, I don't know, let's say 8.41 divided by, let's say 10.26, something like that. Estimate an answer. Now that's quite a difficult one straight off the bat, but I'm asked to only estimate, so I want my first significant figure. So if I start numbering 1, 2, 3, 4, sorry, 1, 2, 3 is a different number. 1, 2, 3, 4. Now that is a 0. It is still a significant figure, second significant figure, because it's not the first one. So you can number that as a significant figure because it isn't the first one. Okay, so let's round this. So that's going to be 8.41. Rounded to 1 significant figure is 8. 10, so it's either going to be 10 or 11. That's a 0, which is definitely less than 5. So that's actually 8 over 10, which gives me 0.8. And again, on my calculator, if I have 8.41 and I divide it by 10.62, I end up with an answer that is 0.819. Okay, 0.819. 0.8, very satisfactory estimate to this. So I can say that that is approximately 0.8 as an answer. Alright, I hope that answers a few questions you've had on rounding and estimation. Please make sure you've noted down those points as well as this one here. If you have any other questions, put them in the comments below, or have a look on YouTube for some of the videos, perhaps have a look on Khan Academy, or even ask your teacher. Alright, thanks very much. I'll see you next time. Cheers.